All right, here's a walkthrough for the practice final. It's only going to be able up until the day time that the practice final or the final starts. Once the final starts, I'm going to take it down. So you kind of want to watch this before then. It'll be next week. We're getting there. So let's just take a look at what we're doing. In fact, I should be able, may not even need visualizer anymore, my pin pad, so we can walk through it right here and I'll just type on the screen what I'm thinking. You know what? I'm going to keep that list available like I was telling you about. So I'm going to make a list real quick. I'm going to say I've got a confidence intervals. I'm going to mark them down and cross them off as I do them. I've got proportion and I've got mean. And then my hypothesis tests. I've got 1p, 1 mu, 2p, 2 mu, and the paired test. I've got goodness of fit. I have chi-square. And I might use the word mu. I don't know how to type the Greek letter mu in typing. And then we have Anova. Those are our 8 options. And as I use them, I'm going to cross them off. And I might even put which problem I did them on. So at the end, I can go back and look at it. Looks like I could open this window up a little bit more like that. This is how I would take the test if I were you, like that. So the instructions should remain on the top of each page. That way you can remember what's being asked. Question 1. I just rotate that a little bit. Question 1. In 2009, a researcher believed that over a quarter of American teenagers ages 16 to 17 send text messages while driving. When surveyed, 83 teenagers out of 283 responded that they had sent a text message while driving. Test the researcher's claim using a significance level of 0.05. So it doesn't say proportion and it doesn't say mean anywhere, but it is only talking about one group. So I know this is a one group test. And it looks like it's a yes or no category. Did you send it or did you not send it? When they give me a number out of another number, this sounds a lot like a proportion. So I am going to type in my response, this is a 1p test. And I know H naught for a 1p test is P equals. Well, I don't know what the value is. I can grab a calculator if I want, but I know it's 83 out of 283 by what they give it. Or you can put the actual value, P equals 83 divided by 283. Clear, I'm hitting the wrong numbers. I'm getting, let's see, 0.2933. And so HA, it says over, so they think the proportion's higher. So P should be greater than that 0.2933. Or the fraction if you chose to type the fraction. So that's my H naught and HA. This was problem 1. I'm going to mark that down real quick. 1. I want to give a decision area. So make a decision. I'm going to compare p-value versus alpha. Let's see, my p-value is 0.04. That is less than alpha at 0.05. So p-value is less than alpha. I'm going to reject H0. I'm going to support HA. And now I'll get down to my statement of conclusion. We're supporting it. And the researcher believed that over a quarter of American teenagers send text messages while driving. So there is sufficient evidence to support the researcher's claim that over, I'm literally typing what I see it there, a quarter of American teenagers ages 16 to 17 send text messages while they drive. And I didn't mention this is an optional part. You probably should do it. You should say what level of significance. At the 0.05 level of significance. So that's question 1. Bam. Any questions? So what I looked for here, it doesn't say proportion, it doesn't say mean, but it does only talk about one group, American teenagers. So I narrowed it down to being one of these two. Giving one number out of another, or an example where they have a yes or no, off or on kind of thing. Do they text? Do they not text? Tends to be a proportion. Means tend to have decimal places, and means will usually give you a standard deviation. So I don't think it's in that category. I'm pretty sure it's the 1P. I know it is because I'm the teacher, but if you're wondering about it, that's a good way to reason it out. Okay. So the question, the prompt is still up there. Question 2, in a survey of 1,000 women with full-time employment, 540 indicated they would sacrifice some personal time in order to make more money. Give me a statement of confidence at the 95% level if these are the lower and upper bounds. So they're not giving me a mean, and this is specifically a confidence interval, so this looks like a proportion. This should be number 2. And so for the proportion or the confidence intervals, we got to enter a statement of confidence. And they told me the confidence level, 95%. We are 95% confident that, and this is a proportion one, the true proportion of women with full-time employment that would sacrifice some personal time in order to make more money is between 0.5091 and 0.5709. That is one way to write that sentence. Alternatively, you could do the following. If I turn this to a decimal by moving the decimal, or a percentage by moving the decimal place over twice, I could say 50.91%. And we'll move it over twice here. I think the second way is more readable, but you do have to do a little more work. Like it means more to me in my head. Between 50.91% and 57.09% means over half. For the one with the decimal in it, it means less to me because I have to stop and think about what it means. Whereas the sentence with percentages just tells me what it means right away. I will take either. Any questions on that one? All right, I'll go to the next problem. A hotel chain is interested in customer satisfaction with their reservation processes. Of the 80 guests who reserved by phone, 57 indicated they were satisfied. Of the 60 guests who made online reservations, 49 were satisfied. Is it reasonable to conclude that the proportion of people who are satisfied with online reservations is greater than those for phone reservations? Test the claim at the alpha equals 0.1 level of significance. Well, they told me proportion right in the problem, which helps. This makes it easier. They are talking about two groups. They're doing a comparison. Online groups versus phone groups. So this is a proportions test, and there's two groups. This is a 2P test. This is problem 3. Which means I need to label groups. I'm going to write what H0 and HA are first. P1 minus P2 equals 0. And HA is P1 minus P2. I'm going to make it match what it says here. Are online reservations greater than phone reservations? Online greater than phone. So I'll use the greater than here. And that means this is, you do that. I want the same thing. Online is greater than phone is the same thing algebraically. This is group 1. Group 1 is online, and it's greater than group phone 2. Another way of writing these is P1 equals P2. Oh. And P1 is greater than P2. Here's what StatCrunch used, which we're more familiar with, but they mean the same thing. Just a little bit of algebra manipulation to get between them. So I marked my group down up there. I don't need all that space. I got my group marked down up there. I need to make a decision. So I've got my p-value equals 0.0775. And I've got my alpha, 0.1 is my alpha. It looks like the p-value here is less than alpha. Notice the alpha is not 0.05. If it was 0.05, the results would be different here. But alpha is not 0.05, where it would be greater, here it's less than. For less than, we reject H0, we support HA. So my statement of conclusion will be about supporting HA, which means there is sufficient evidence to support the claim that I'm going to go back here and answer this question. Is it reasonable to conclude? I can literally take the rest of that sentence, that the proportion of people who are satisfied with online reservations is greater than those for phone reservations, and I can paste that right here. I'm going to reread it out loud to make sure it makes sense because I want to make it sound intelligent. There is sufficient evidence to support the claim that, nope, I got too many that's there. There is sufficient evidence to support the claim that the proportion of people who are satisfied with online reservations is greater than those for phone reservations. And now I'll include at the 0.01 level of significance. That's my 2P test. Any questions on that one? Notice I've got test stat here. It doesn't say T stat or F stat or anything like that. Some students got used to recognizing what letter meant what. So I'm just giving the test statistic, what the value is. You should be making your decision based on what p-value is and recognizing what type of test it is from the word problem. Here they mentioned a proportion, they mentioned two groups. Even if they didn't mention proportion, they gave me out of 80 guests, 57 were satisfied. Out of 60 guests, 49 were satisfied. Those are proportion amounts. Okay. Question 4, in a sample of 400 undergraduates at a mid-sized public university, it was reported that the mean time spent studying for the final exam in a stats class was 7.74 hours with a standard deviation of 3.40 hours. Give me a statement of confidence at the 95% level if the lower and upper bounds are as follows, and they're given to me. All right, so this is a statement of confidence. We've already done proportion, which means this is the means test or means interval. And I'm using the percentage right there that says 95%. That the true mean student undergraduates, I'm pulling information from the question. We are 95% confident the true mean of undergraduates at a mid-sized public university spent between, and I'm going to use the lower limit, 7.4103. The time unit is hours right here. So between 7.4103 hours and the upper limit is 8.0697. That's also in hours. And what they were doing was studying for the final exam in the stats class. So once I've got it typed it in, I'm going to read it out loud, make sure it makes sense. We are 95% confident that the true mean of undergraduates at a mid-sized public university spent between 7.4 and 8.06 or 8.07 hours studying for the final exam in the stats class. That sounds good. That makes sense to me. That's it for that one. Generally, the two confidence interval ones are only missed by students that never watch any of my lecture videos or content. I wrote all the confidence intervals like this when we were doing confidence intervals in chapter 9. And I've used this repeatedly. So those are two fairly easy ones. I just used the percentage. I said, we are confident. I rephrased the question into an answer, and I used the numbers they provided. That's it. All right, we'll go to the next one. Here's an interesting question. Does time seem to stand still for smokers that abstain from nicotine? After a 24-hour period with no nicotine, 20 smokers were asked how much time had passed after a 45-second interval. The sample mean was 59.3 seconds with a standard deviation of 9.84 seconds. Test the claim that nicotine abstinence for smokers leads to overestimating how much time had passed at 0.01 level of significance. All right, so right away I can see that they said sample mean. This is definitely a means test. If I go through it, I only see one group. They're asking about smokers. So this has got to be a one means test. This is number 5. I don't know how to write one means, so I'm going to put 1 dash mu, or you can put 1 dash u. Either works here. I do know that H naught u or mu has an equal sign, and HA said I will use u or mu. I'll put the same thing, depending on what you type. Do I want greater? I don't want equal sign. It says test the claim that abstinent smokers is overestimating. Over means larger, so it's going to be larger than. So now I got to figure out what that value is on the right. It's easy to want to go with the 59.3 seconds, but that's the sample mean. That's not going to be it. I'm thinking if you're not on withdrawals or you're not drunk or something like that, 45 seconds hopefully feels somewhat like 45 seconds. Some people will overestimate, some people will underestimate, but the average of all the groups should be that 45. So mu equals 45 seconds, which means HA it's greater than 45 seconds. All right, I'm going to make sure I'm good with that. They were asked how much time had passed for 45-second interval. That should be the average to get the actual time. So this looks good. I think that's good. So I'm going to make a decision. My p-value is 0.0001, and alpha is 0.01. Again, alpha was not 0.05, but in this case, we were still less than. So this was when we're less than, we reject H naught, we support HA. I hope my practice exam has a couple that are not less than. So my statement of conclusion, we're supporting HA. HA is that nicotine abstinence for smokers leads to overestimating how much time had passed. There is sufficient evidence to support the claim. And then I copied that so I can paste that here. There is sufficient evidence to support the claim that nicotine's abstinence for smokers leads to overestimating how much time passed at a 0.01 level of significance period. All right, we're doing good here. I'm going to click next unless you got questions. Question 6. A Facebook study investigated the relationship between college GPA and Facebook use, where the researchers believe that the GPA for college students who use Facebook was lower than that of college students who did not. That sounds like an HA to me. I'm actually going to come down here and copy that. I'm going to paste that in here for use later. Sounds important. Of the 141 students who used Facebook, they had a sample mean of 3.66 with a standard deviation of 95. Of the 68 students who didn't use Facebook, they had a GPA of 3.82 with a standard deviation of 0.41. Test the researchers' claim at the 0.01 level of significance. All right, I'm seeing two groups. I'm seeing the group that used Facebook right there, and I'm seeing the group that didn't use Facebook, and they each have their own mean and own standard deviation. GPA stands for grade point average. So it's actually an average of averages. That's fun. But there's two groups, and this is talking about a means. This looks like question 6. And the groups are not the same size. I've got 141 and 68, so it cannot possibly be paired. It's got to be the 2 mu 1. So this is a 2 mu test. Which means I need to identify them. And I kind of want to put it in the same order I see down here. So I'm just going to make some notes for myself right up here. FB users was lower than non-FB users. So let's call Facebook users group 1. And non-Facebook group users group 2. Totally got my fingers on the wrong key. Oop. This helps me with my H0. U1 needs to be less than U2 because that's what my thing here says. Or you can put U1 minus U2 is less than 0. Either one of these works. You don't have to put both. But the same style should match what you do in HA. Oh shit, that was my HA. H0 is a statement of equality. Look at me fucking up. Don't do that. Don't do a Mr. Jones right there. Change those to equal. H0's always got an equal sign in it. Look at that. All right, so I've labeled my test. I've identified my groups. I've given my null and alternate hypothesis. Now it's time to make a decision. And I have my p-value is 0.0455. And I'm comparing that to alpha. 0.01 is alpha. Here it's larger than. So here we do not reject H0. do not support HA. So make a decision. I've got do not reject H naught, do not support HA. If we're not supporting it, there's not enough evidence. There is not enough evidence to support the claim. And I actually copied and pasted what I wanted already. I just put that up there. Let me make sure that makes sense. There's not enough evidence to support the claim that GPA for college students who use Facebook was lower than that of college students who did not at the 0.01 level of significance. Notice if alpha here was the regular, the 0.05, this would be the opposite. The p-value would be lower, which means we would support HA. So you need to look at that level of significance here. I think that level of significance for this type of problem is a little unrealistic. I would probably in real life use 0.05 because this is a little strict for something that's not as important as going, hey, does Facebook lower GPA average? So while is this statistically significant? Or I guess it's not statistically significant because we didn't support it. I don't know. This is what I would do. Reading it though, I would go, okay, the average is lower for people that use Facebook. Maybe I should use my social media less as a student. Again, it's all about times and how you're doing. All right, next one. The cost to charge ratio percentage of, which is a percentage of billed charges that are actual cost to the hospital, are listed below for 6 hospitals in a specific state in 2002. Is there sufficient evidence to conclude that the cost to charge ratio for outpatients costs is lower than that of inpatient costs? And they give me a test statistic of 8.1 and a p-value of 0.02. All right. So I got a conundrum here. Which test is it? This is kind of table-ish. So the chi-square is a table. But I don't think whether they're comparing hospital to inpatient ratio is what they're really going for here. They're comparing inpatient ratio to outpatient ratio. So I don't think the actual hospital has anything to do with it. In fact, I think maybe they're listing the hospital to show that they go together. So this is leading me strongly to suspect paired. There's no proportions listed, so matching percentages isn't going to work for goodness of fit. Anova, I only have 2 groups, so I can't do 3 or more means. This is looking strongly like 7, but I'm going to put a question mark next to it. So if I need to come back later and change it, I can. But for now, I'm going to go with paired test, which means I need to label group 1 and group 2. And it's all got to be about what their claim is. Is there sufficient evidence to conclude that the cost to charge ratio for outpatient costs is lower than that of inpatient costs? I'm going to copy that down. That sounds like part of my HA and part of my statement of conclusion. So I'm going to come down here and put that. But it also tells me what I'm comparing. Outpatient is lower than inpatient. So out is lower than in, which means I'm going to call group 1 is my outpatient. And which means group 2 will be my inpatient. And so H naught, P1 equals, not P1, mu. Mu1 equals mu2. Or we could do, put some space here. Or you could say mu1 minus mu2 equals 0. I guess since this one also used in StatCrunch used mu d, I could say ud like that maybe. Although I don't know that I like that. Maybe I'll do this. Mu underscore d equals 0. And then HA is that outpatient is lower than. And then you can do the other options or other options with the same symbol. All right. So now I need to make a decision. Make a dish. So my p-value is 0.0002. My alpha listed above is 0.01. Even though my alpha is low, my p-value is lower. So my p-value is too low. I'm going to reject the hoe. Reject H naught, support HA. And that gets me down here. I'm supporting it, so there is enough evidence. Oh, I already got that listed there, right there. Look at that. There is sufficient evidence to conclude. I don't want to conclude. I want to support the conclusion or claim. We can go with conclusion since they say conclude. Is lower than that of inpatient costs at the 0.01 level of significance. All right, we're almost done. We've got 3 problems left. It's been 35 minutes, so we're making good time. We got plenty of time. In a study, the Yankee Stadium had 99 home runs classified by what direction they were hit. Is there convincing evidence that the proportion of home runs hit are not the same for all 5 directions? That sounds like a statement of conclusion or part of the statement of conclusion. So which tests of the ones that remain talk about a proportion not matching? Anova is about means. Chi-square is about rows being dependent of columns. I've only got 1 column of data here. I don't think that's it. This looks like a goodness of fit test. This is a goodness of fit test. And for that one, all proportions, let's see. Well, it's going to be the opposite of what the sentence says. The proportion of home runs hit are the same for all 5 directions. HA is going to be the same thing, but it's going to say they're not. And I'm going to add a little bit. At least one is different. All right, so I've got my test name. I've got my hypothesis test, my null and alternate hypothesis. I need to make a decision. So my p-value here is 0.0415. It does not give me alpha, does it? If it doesn't give you alpha, use 0.05. Alpha is not given. And here, that means my p-value is less than my alpha. P-value is too low. I'm going to reject the HO. And I'm going to support the alternate. The alternate claim was that there is convincing evidence that the proportion of home runs are not the same for all 5 directions. Convincing works for sufficient, convincing evidence. And I'm going to say at the 0.05 level of significance. And I almost think you kind of need to, because it wasn't given in the word problem, and you want to say what you're making your judgment basis on. I'm going to add Yankee Stadium because it's about Yankee Stadium. Which may not be the case for other stadiums. That'd be specific. I think that looks good. There's no mismatches so far. Okay. Question 9, are babies born using assistive reproduction technology, or ART, more likely to be born prematurely than babies conceived naturally? Almost 20,000 births were classified according to conception method and premature status. Is there convincing evidence at the 0.01 level of significance that there is an association between conception method and being born premature? Okay, well, I've got a table here, right? This looks like a table, and of these two, the table one was the chi-square. And the chi-square test was, in general, rows are independent of columns. And HA in general is rows are not independent of columns. I want to be more specific in this problem. I want to use what they're talking about. HA is their convincing evidence part. So I'm going to copy this. I'm going to put this down here. There is an association between conception methods and being born premature. That's HA, which means there's a relationship when there's dependency. The conception method matters whether or not a child was born premature or not, or vice versa. Which means for this one, I'm going to kind of do something similar, but I'm going to say that there isn't. There is no association. Or conception method is independent of maturity status. I don't know how to phrase that part. That looks good. Is independent of, well, when they're born. That's a better way. So now I want to make a decision. And I've got my p-value is 0.0001. And they gave me 0.01 level of significance. Which is my alpha. Which means p-value is lower than it. So again, this is a reject H0, support HA. Since we're supporting it, there is enough evidence, or there is convincing evidence. And that looks kind of like it. That was my chi-square. That was number 9. The last one's got to be Anova. If it's not Anova, I done fucked up somewhere, right? Something's got to be wrong somewhere if the next one's not Anova. And an environmentalist wanted to determine the mean acidity. I see mean. Acidity of rain differed among Alaska, Florida, and Texas. He randomly selected 6 rain dates at each of the 3 locations and obtained the table of pH levels below. Normal probability plots indicate the sample data comes from a normal population. Test the hypothesis that the mean pH in the rainwater was different. I do see 3 columns of data here. There are no row headers here, so the dates or anything like that don't seem to matter. I got 3 groups and they're talking about mean. This is definitely an Anova. And it says test the hypothesis that the mean pHs in the rainwater are different. That sounds like my alternate hypothesis. So I'm going to come in and paste that in real quick. And I said this was an Anova test. For the Anova test, the means are equal. The mean of Alaska equals the mean of Florida equals the mean of Texas. HA, at least one of the means is different. So I need to make a decision. I've got a p-value of 0.0493. My alpha, I've got listed down here because I copied and pasted it, is 0.05. Just my alpha. P-value is less than it. So again, this is a reject H0, support HA. And if we're supporting it, that means there's enough evidence. Evidence to support the claim that the mean pHs in the rainwater are different at the 0.05 level of significance. I'll probably, I think it to be, if I were to do this in a paper, I would want to be specific and say the states: Alaska, Florida, and Texas. I didn't have to scroll up and grab them because I see them where I put my mean, my H0 right here. And now I've got a statement that could go in a paper. There's enough evidence to support the claim that the mean pHs in the rainwater of Alaska, Florida, and Texas are different at the 0.05 level of significance. Bam. All right, so I did it in 45 minutes. I don't want to submit my quiz. I'm going to go back through it. Can I click on a previous question and jump to? Oh, I can. Look at that. So I would probably, if I had done 45 minutes and I have 2.5 hours, I would probably get up, go use the restroom, get a drink of water, clear my head, come back, don't look at what I've written down, reread the question, reread my answers, and see if they make sense. When I'm confident with that, I will submit quiz. And then I'm just going to wait for Professor Jones to grade it. It's not automatically graded. There's no way to auto grade one of these effectively essay type questions because there's room to type. But that's it. You got any questions? That's what you can expect for the final. The questions will be different, but the categories will all be the same. And what is expected of you will be the same. So I am going to hit stop recording.